Welcome to our design series. Today we want to learn how to design reinforced concrete slab in robot structure. So in our current design, we want to consider the design of this very slab. Now, what we are going to do in this very design is that in the reinforced concrete slab design is that we are going to pick just a single slab panel and design. Then after we are done with designing a single slab panel, we are going to consider the entire slab as a whole. We are going to design the entire slab as a whole. So let's start with just a single span. So when you open robot software, so what you need to do, you click on new. So when you click on new, you come to where you have slab design. So you click on slab design. You click on slab design. So when you click on slab design, you go to your tools, then you click on job preference, where you will start setting performing all the settings. So we start with the units. So we click on units. Our structure dimension is in meter. Then the section dimension is in millimeter. Then we have the section property. The section property will also be in millimeter. Then the diameter of reinforced concrete bar in millimeter. Then the reinforcement area will be in meter square. Then crack width will be in millimeter. So we are done with that. Then you click on force kilonewton, then moment kilonewton meter. Then we have our stresses to be meganewton per meter. Then you go to others. Don't touch anything. The displacement is in mm. Then unit addition, allow it to be. Then for the material, so we click on material, then we come to modification. So under modification, we select our steel. So we have the 410 steel A, which is what we have. Then we click on OK. Then we click on rear. We click on reinforcing bars. So under reinforcing bars, we click on hero code 2. So we click here. So here we have already set our characteristics yield strength of steel to be 410. So you click on OK. Then you can now click on save current parameters. You click yes. You save current parameters. Then you click on OK. So you click on OK. You click on OK. So after the setting, the next thing we are going to do now is for us to go to our axis definition. So you click on the axis definition. So we close on axis definition. So now what we are going to do right now, what we are going to do is for us to go back to our drawing. So we have on the X we have 3825. So on the X axis we have 3825. So we click on the X axis, then we add this. Then after that we click here 1, then we now 3.825. So you click on add. Okay, then you go to the Y axis. Then we go back. So this is 5425. 5425, 5425. So we put 5.425. So here we will change this to ABC. You click on add. When you click on add, you apply. Okay, so we have been able to create our this thing now. So after we have finished creating this panel, you click on geometry, then you click on objects, then you click on poly contour. Click on poly contour. So when you click on poly contour, you allow it to be on contour. Click on contour, then you now draw the contour line. From there you close. Okay, after we have done that, so we go back to axis definition. When you click on axis definition, you come to axis manager, uncheck the structure axis. So when you do that, you click on OK, then you close. So we have done that. Okay, so now the next thing that we are going to do, we want to define the thickness of the slab. We go back to geometry, we go to panel, we click on panel. So when you click on panel, you come to where you have reinforcement. So under reinforcement, you click. So when you click under reinforcement, so we start with the general. So this is the general. So we can now rename this. We can rename this as slab. And rename this as slab design. Okay, rename this as slab design. Then we click on simple bending. Then under material, you allow it as in a structure model. So we have already done the setting. So here we have the structural class. This will be class 4. Then ductility class is C. Then grade here is this one, which is 410. Then under serviceability parameters, we allow everything to remain the way it is. Okay, here we click on XC1. Then concrete age, this would 28. So we click on 28. Then under reinforcement, here our concrete cover is 20. This one also is 20. So you set this. Then the concrete the main diameter is H12. Allow everything to remain in H12. Then our deviation, standard deviation is 10 mm. So we are okay with that. Then under here you allow for the whole panel. So you click for the whole panel. So you click for the whole panel. Then you go back to general. When you go back to general, you click on add. So we have added that now. So the next thing that we will do is for us to define the thickness. So we come here under this. So let's change this to 150. We can call this Okay, uh, uh, let's call it panel 7. Let's call it P7. So that is our panel description, P7. Then here is 150. Here is 150. Then for the material, we have 20, C2025. So our material is okay. And all these settings are under homogeneous. Okay, so when you are done with that, you can click on add, then you close. So for you to add this material, the thickness of this material to this, you simply click here, then you click here. So we have added that now, so we can close. Okay, so the next thing is for us to create a support. So you come to support, you click on support, then click on linear, then you click on pin, So under pin, you don't check anything, you just allow everything to be the way it is. Allow everything to be the way it is. Then you come here, you click here, click here, click here, then you close. So let's go to 3D now. So you can click on 3D, then you zoom. So we have zoomed it now. Okay, so from here, the next thing we will do is for us to go to merging. So you click on option of FE mesh generation. So you click on that. So when you click on that, you come to where you have merging option. So you change this to 0.1. You click on OK. When you click on OK, you click, go to analyze, click on generation of computational model. It's okay. So we are done with that. So everything is okay. So we have finished the generation of that. So let's go to loading. So we click on load type. So here, this face load, which is dead load 1, is actually the save weight of the slab. So the next thing that we will do is for us to add dead load from slab. So dead load from slab. So we can add. Okay. So after that, we click on live load. Live load from slab. So you can add the live load from slab. Okay. So we close. So we go back to load. Click on load definition. So we want to start with the dead load from slab. So dead load from slab. You select dead load from slab. Then you come to surface load. You come to this. So when you click on surface, you come to this one, uniform planar load. Now let's go back to our design template. So the load that we are going to put now is going to be dead load on slab, which is this one, 4.47. By now we should know how we arrive at this 4.47. So we come back here, we put minus, because the sign convention is all the load that's coming vertically downward to have a negative sign. So we click add. So we come to this one, we put, because the value, the description for our thickness is 1. So we click we click one, we click on apply. So the load has been applied. So we go back to live load. Go back to live load, the same surface load. We click here. Then is the live load here is 2.5. So we come back here, minus 2.5, minus 2.5. We click, then we click. So we are done with the application of the load. So we can close. We can close. So we go back to load, click on manual combination. So we want to perform the load combination now. So for the load combination, the first one that we are going to consider is going to be combination 1, which has to do with the ultimate limit state. So we just allow it to remain at combination 1. We click on OK. So when you click on OK, you come to structure, because under structure we have the dead load, the save weight, and the dead load from slab, dead load from slab, or dead load on slab. So anyhow you want to call it. So we click here to move everything in. Then we click on category A, where we have the live load. So we also push everything in. Then we apply. When you apply, we go to new to change the load combination to serviceability limit state. So under serviceability limit state, we have combination 2. So here we go back to structure, dead save weight, and dead load slab. So we push everything so that it will multiply. This is a factor of safety for the for serviceability limit state. So it will multiply everything like this. Then we go back to category. Under category, we also move everything. Then we apply and close. We apply and close. So we can now run our analysis. So let's run the analysis now. So we calculate. So the calculation is complete now. So everything is okay. No error, no error. So let's quickly go to the results. So to get the result, we click on maps. So you click on this. When you click on maps, you can actually check the bending moment, and we can also check the displacement. So let's check for the bending moment first. So we click on description. So we can click on open new window. We click on this. So this is the bending moment on the x-axis. The bending moment on the x-axis. So you can see where the maximum bending moment occur. You can see where the maximum bending moment occur. So we can equally check for deflection. We can check for displacement. Sorry, we can check for displacement. So we apply. So this is the displacement. Now, if you want to check the result of everything, you can click on the slab and share result. So when you click on slab and share result, it will bring out a tabular form. Then, so we can now check on all the moment on the x-axis, and moment on the y-axis, and moment on the xy axis. Then we can as well, if we want to add the displacement column, so we can do that. So when you want to do that, you click on special, and we click on, we click on displacement. When we click on displacement, we click on OK. So this is the displacement column that has been added. Then for us to check the maximum value, we just come to global extreme. So this is the maximum moment. This is the maximum moment on the YY XX axis, on the YY axis. Then we have it on the XY axis, and this is the maximum uh, displacement. Okay, so let's move. Let's close this and move. So we click on here. So we can close that. We can close that. We can close this, and then okay. So let's go to design. So we go to design. We click on require reinforcement of RC slabs to wall. So when you click, this window will come up. So when this window come up, all the dialog box will come up. So what we are going to do now is that we are going to select the ultimate limit state. So you click on the ultimate limit state. You click on combination. You click on combination 1. Close. So to bring it out. Then under serviceability, the same thing. Click here. Combination 2. You close. Then here you have already gotten this. Then you select this reduction of forces at support and all those things. When once you are done with this, you click on calculate. Okay, so you close this. So now we want to check the area of reinforcement now. The area of reinforcement require. So to do that, you just click on this one. When you click on it, you come to with description. Then you can open this with a new window. You click on apply. So from here you can see, so you can now see that this is the area of reinforcement required for this slab. This is the area of reinforcement required for the slab. That is why we have this very color, which is the thickest. So we have 452. So this is the area of reinforcement that is required for the slab. So let's make provision for area of reinforcement provided. So for you to do that, because this is the area of reinforcement required, so you have to provide something that is higher than this. Just like when you are designing a normal slab. For instance, now design a normal slab, then here you have this is the area of reinforcement required. Then you have to provide something that is higher than this. So that's the same thing that we are going to do. So for us to make that provision, so what we need to do is that we come to where we have provided reinforcement of RC element. So you click on that. Then you come to this point here, and you double click on it and wait. So it's bringing this one out now. Bringing this. dialog box out. So x negative, x, y negative, and then x positive, and x and y positive. So we go back to x negative. Now we're going to start with the setting now. Under bending, under bending, okay. So under reinforcement map, you have to uncheck this. So you have to uncheck this, then uncheck this one. If it was checked, you uncheck it, then uncheck reinforcement direction. So when you uncheck reinforcement direction and every other information, you can now come to calculation option. Now under calculation option and under general, you don't touch anything here. This is our concrete cover. These are concrete cover which we have already set. Then under concrete, you don't touch anything there. But under reinforcing bars, you can now select H12, can select H12, and select H12. Then this one is selected automatically. Ductility class class C. Then for wire make, for wire fabric, you don't touch anything. Then reinforcement for punging, here you can select H12. Then when you select H12, you can go back to general, then come to save as. Let me save this as 18. Save this as 18. So that is the name we have saved. Then you click on OK. Then you come to reinforcement parameters. Click on reinforcement parameters. Then under bar, you select this to H12. Select this to H12. Select this one to H12. Select this to H12. Then under spacing on x-axis, I want to use 200. This one I want to also use 200. Remember that using 200 will give us area of 566. Area of 566. Then on this other side, I will also use 200. Then here I will use 200 also. Okay. So for preferred reinforcement spacing maximum, I will also use 200 here. Then come here, I will use 200. Then on this, I will use 200 also. I will use 200. So I've set everything. Then under this one, you don't touch anything. Under constructional reinforcement, I will click on this. Then under shape, I won't touch anything there. Then I go back to general. I come to save as. I will put this as 18. Okay, so I will click on OK. So after I've done that, the next thing is for me to calculate. So I will come to calculation. I'll click on calculate. Okay, so it has finished the calculation now. It has finished the calculation. So what I'm going to do right now is for me to view, okay, before I go to view, let me now click on reinforcement. So I click on RC design I'll go to slab reinforcement. Okay, now without you running the design, without you running the design, you can't have this slab reinforcement. The reason why we have this slab reinforcement is because we have run our design. So we can now look at this. We can now look at the reinforcement. So we have the reinforcement at the support and the reinforcement at the bottom. So for you to have the detail of the reinforcement, you click on detail. So you will see here, these are your diameter of reinforcement that has been designed. So let me click on this. So you can click this for you to check, and click this. You can click this. You can click this for you to check. So we have finished designing our slab. So let's go back to a design. Let's go back to provided reinforcement. So we have done this already. So you can see here that we have the design is H12 at 200, which is what we have. So, and it's spanning from here to here, Now, when you click on this, the X direction, X negative, you also see the reinforcement is spanning from here to here, which is also H diameter H12 by 200. The same thing here. You also check it out. You see here H12 by 200. Then Y positive, which is spanning from here to here, H12 by 200. Okay, so we can actually get the calculation node. So to get the calculation node, all you need to do is you click on calculation node. Here you can select what you want, but you want everything. So you can see here that slab palette number 1 reinforcement. So you have the reinforcement here, slab design, and the type slab design. Then we have the bar diameter. For the bottom we have H12. For the top we also have H12. Then cover C20. For the bottom, for the tops 20 also. So you see that cover deviation is 10 mm. Then class C2025 characteristic strength of the concrete, which is what we use for our design. Then let's go to the bar spacing. You see our bar spacing, maximum bending plus reinforcement for bending. As you see here that this is what was required. Then let's go forward, and this is what we have provided. So provided reinforcement. This is what we have provided. So this is the provided reinforcement. So meaning that required is less than provided. So our design is okay. So you can print this, you can save this file and print it in whatever form that you want. So you can save this file, you can save it, you can save the file, you can save this file, or maybe I can use, okay, let's print it. Let's use printing, for example. So let me use printing so all pages. So we are doing all pages. So I can now click on this Then I can save it on my desktop. I can say robot slab design 2. Robot slab design 2. I'll click on save. Click on save. So we can check that. We can check this out. So you see it here. So look at it here. So this is the calculation sheet now for the slab. So this is your calculation. So that is how you can design your slab, the reinforced concrete slab. So in our next uh, class, we are going to see how we can design the entire slab, meaning that how we can design the entire slab. Thank you very much. So see you in our next module. Bye.